This is vvvvTv.
And in this episode, we are going to talk about massively multiplayer interactive experiences that we're building with vvvv and WebSockets. Anton, the scenario is this. We have this huge installation, full dome experience. People come in with their phones to take part in this installation, and they can control an avatar on the big screen. Right? So
at the same time.
All at the same time in parallel. And operator, can we show the screen? So the gray area down there is our full dome output particle system.
Many GPUs.
Everything. And so the users come in, pull out their phones, and we tell them, please navigate to this website. What do they see?
Super fancy UI.
Super fancy, customized UI, individualized for them. And this is where they can control the parameters of their avatar. So you can give them a name, can change the size and color. And then already the next user comes in, does the same. And we see the full dome experience filled up with joy of all the particles that are joining this experience again. There is no better word than just this. So we have, meanwhile, 3 users, and we're just showing that now Jorek has something better to do, and he leaves. But the others are still staying.
Still playing.
And maybe someone else is joining now. Customizing their avatar. You get the idea. We have people coming and going, and everything is instantiated in real time. Dynamically. Obviously nothing fancy here. We try to, as usual, strip this down to the bare bones essentials that you need to understand to build such a system, and you put in the fancy bits.
So now everybody goes home.
Now they're all going home, and our installation is empty again.
Then someone comes.
Someone again coming next day, okay. And so on.
And so on.
Yeah. We're using as a backbone here for this multiplayer installation, we're using WebSocket server. Why was that?
Because it's the easiest way to communicate from the website to vvv. Because WebSockets are HTML5 standard, so it's super easy to use from the website. And in vvv we have a server, so we can handle multiple connections. So every website connects to a web server and send us data, and we send data back.
So since our main goal was to have people control this from a website, we're using WebSockets as a technology to make the connection there. So this is the patch we see is all that this demo needs. Just briefly walking us through what we see.
Yeah. So we have a web server, a WebSocket server connected to this IP address and the port.
Maybe show again, if you now open the website, we see a connection is established.
Yeah. Then we get the messages. For example, if I change something, the new message comes in.
But also, as soon as the client connects, they send an initial information about the avatar, and then every time it changes, they send information.
Exactly. Yeah. We deserialize the data, put every client in a dictionary, which is the client IP to the data type.
Yeah.
And for every client, we just update them, draw them, and as additional thing, we send their position back to the website.
Just to demonstrate
that it works.
that we can also send something back.
Yeah. And then when the clients go away, we remove them from the dictionary, like this. So this is for the vvv part. I would say we check the website as well.
Yeah, let's have a brief look at the web parts of this. So this is the website. It's super minimal, just the form with a slider and
Just a script and the super simple form.
Yeah.
And the script is
where the interesting parts happen, is the script.
But again, it's just a standard. So we have a WebSocket connected to this IP and the port. And on open, so when we connect, we send initial data. If we check the send data function, so we just serialize our form and send it.
Yeah.
And
As
then
a
we
JSON thing, and then
yeah. And then for our form, we add a listener. So if something in the form changes, we send the data. And the form is this, the whole thing.
That's really all we need to know. This is not a JavaScript tutorial, so that part is for you to explore more. But let's now concentrate on how we built this from kind of scratch. We prepared certain elements, but if we close this, like this is an empty patch where we have prepared a few things that we will show you in a bit. So how would we start now?
So where the WebSocket server. So let's put a note. So we already installed this NuGet.
Yep.
And it pops up in a node browser. So we just reference it and we say, okay, where WebSocket server. We provide the IP address and the port, and we know that the port is 4444. And by the way, if you try to connect to some server and sometimes you can't establish the connection because some ports are blocked on the browser side or in a firewall. So
networking and port is always something to figure out if it doesn't work instantly.
Then
so now we're listening.
We're listening and nobody is connected. But let's try to open the website.
As soon as we open the website,
JavaScript starts the WebSocket client, connects to the server, we get the connection.
Yep. So, and we know from the script that it immediately sends a message on connect. So maybe the first thing that we want to do is like receive this message, and as you mentioned, like parse it and make a client representation out of it.
But let's do this for the message is not the first one, so which right away for each. So we see that the messages are coming. They are coming as observables.
Yeah.
So we need for each reactive connect like this. So when the message comes in, we have it here. So let's go to the WebSocket server. Now, where was it?
Message. VS message.
And we get the data out from this.
You have the advanced mode on, which you could disable.
Okay. This message, and we split it as well, like this. So let's connect to the output, so the region is active. And now we convert the data. It comes as a byte array. So we just need a string from that. From byte, we need a advanced for that. From bytes, string.
Yep.
Like this, and let's just log it.
For now, let's just see what comes in.
Like this. Let's open the log window. And let's see what we get. So we see that the JSON comes.
It's just the serialized information of this form.
The color, name, size.
Okay. So what next? We want to kind of make this into an object on vvv side and store it in the dictionary.
Mm-hmm. Yeah, because for every client, we'll have our persistent entry. Let's make a dictionary.
Yeah. Regarding the dictionary.
Yeah, so clients.
What kind of dictionary do we need here?
We have to use ConcurrentDictionary because this is running not on update, but when the message comes in. So we run into a situation when we try to go over the dictionary to draw all the clients. And at the same time, new message comes in, I want to add a client. So there is a collision. So we need to use ConcurrentDictionary.
Which,
in this case,
makes sure that things are not happening at the same time.
Yeah. So ConcurrentDictionary is an advanced category. So we create it. And we put it in on create operation, like this. So then I guess I will pull in the rendering part, which we already prepared.
Why? Let's just put in a set item. No?
Okay. Because I wanted to show the data types. Set item, ConcurrentDictionary. So we want to add there. And we've prepared the data type client. We will have a look. What is this? So we create a client. And client takes remote data. And this is exactly what we become from the website.
It's kind of the form data. We could have called it form data because that's what comes from the form.
Yeah. So we need to deserialize. So this is the string we know, and this is the JSON string.
We know it's a JSON string. So how do we deserialize from JSON?
We need I can do this like this, or I just open the browser and I type message pack.
Yeah, message pack has the JSON serializer and deserializer in there.
Deserialize JSON. So we deserialize this string into the remote data type. And this client,
I think we should mention at this point that we have prepared them.
Yeah, we will have a look at them.
Okay.
So, and we put this into dictionary, and the key.
What's the key?
The dictionary is a key value pairs, and there can't be two items with the same key. So their keys are.
We need a unique key, but where do we get it from?
We make it simple. So the key will be just IP and the port of the
connection.
WebSocket client. So, and we get this from the, when we split the VS message, we get the IP port, and we use this as the key. So let's have a look now. There we have one entry in a dictionary with a IP port and the data type that we have there. Now let's have a look at what is client. So the client has this remote data. It has on update, it has a wanderer, so it will move. And it has just split operation.
Split operation where it returns the remote data and the position.
If you want to look what the remote data is, we can just search for remote data. Remote data.
Because it's defined in this same document.
And remote data is just a collection of the fields. So it's a color, size, and name. So exactly. So what was this?
Alt-Shift-A just gives us...
So we are now in definitions. And we see what we have. We have a client, which is a class. because we have this living thing here, which moves the particle. Then we have this remote data, which is record because it's just a snapshot of what data comes in. And we have our view, which is just skier nodes.
Drawing the avatar.
Yeah, it can be very, very fancy 3D things here.
It will be. When you do it. Now bring it in. We prepared this drawing part.
So you see it's just a renderer. So this window, then for each something, we split it and we get a client which we update and
then draw.
So let's connect our dictionary there, and we have this client because we have one connection, one thing there, and it lives because it has wanderer inside. So
now already, if you start a second client, they do both live inside this dictionary. We
can check it. There's two items.
Yeah. And they live there. Yeah. But now,
if we change something here, you see that
the red avatar is always jumping back to its origin. Why is that?
Because when the message comes in, we create a client. So on every new message, a new client will be created. So the
whole data is reset.
Yeah, it's just a new thing. What we need actually, if the message comes in, we have to check our dictionary. If there is an item already with this IP and port, then we have to set a new remote data
on the client, on the existing instance.
On the same client, and put it back to the dictionary.
Okay, let's do that.
Let's do that. So this is our key. So let's try. So concurrent dictionary, try get value. Like this, dictionary there.
Yeah.
So, and this is the key. And we get result, which is Boolean, and value client. So if there is such a key, we say client set remote data. So this client, we set this remote data. And we do it like this, and it goes to the set item of the...
And maybe connect the set item to the try get value?
Yeah, sure.
Okay,
so just to repeat it. So we try to get, exactly like this. So if the message comes in, we check if this key, this client, already exists in the dictionary. If it's true, then we just set a new remote data on this client. And if not, a new client is created and is written to the dictionary. So now if we change something here, why so? Maybe because we're paged while we were running. No?
See,
wait. State like this. Yeah, we forgot the link.
Yeah.
Because it says null reference exception because it was such a client there in the dictionary, but we tried to set and this was not connected. So it was right.
Going over.
So now if we change, you see it's changed the size and the name, but it's moving correctly.
It's not resetting because we're keeping the instance and just updating it.
Yeah.
Create another one.
You don't believe me?
No. Always check.
Yes.
Looks good.
Satisfied. Good.
So what's missing now? We have the most important parts are covered, but we had this
Sending back.
Sending back. So just to demonstrate that you have a living connection from each of the websites to the WebSocket server, that means you can send in both directions. And just as an example, we say, let's set back the position that we have here from the client. So how is that achieved?
We just take our WebSocket server, send data, I guess, or string.
String,
Okay.
because we serialized it here. I'm just checking our demo. Yeah, we call serialize on this. So if we simply call serialize JSON on the vector, the position, then
you see we get a JSON representation of this, and we send the data, but where, to whom we will send it. And we know that the keys in our dictionary is already port, IP and port. So we send to the key like this.
So each of the phones of the visitors only gets exactly their avatar's information back, which we should
apply.
See now.
And now you see that there. Okay.
And I guess the final thing missing is how can we make sure that the dictionary is getting emptied when people leave?
Because now, if we close the clients, we see that
they're still living.
Yeah, because they're still there.
Nobody removed them from the dictionary. So how do we do that?
So let's do it this way. So if something happens, we will define how it works. We will take our concurrent dictionary and we remove, what was that?
Try remove.
Try remove
is what we had here.
Try remove.
And we didn't have an if. Really? Just saying.
Look. Yeah. And we take this one because we will on the key. So the key will say us which item to remove. So like this. And you're right, because maybe we want to remove several items at the same time. So we need a for each, actually. For each item that disappears, we have to remove it. And now how to know?
How do we get a list of IP ports that are leaving the installation?
So let's add someone and someone else.
So here we have this spread of IP port of all the existing connections. How do we get a list of all those that are leaving?
I guess we just take those there now and remove those
that are leaving. That except, let's just build it because it's so hard to talk about it.
So we take except node. So except just takes, it works on the sequences.
We're looking at the sequence now, at the spread of connections now, and also at the one frame earlier.
So we need a frame delay.
We want to compare the current list with the list from one frame before.
Okay. So I guess like this, right?
Yes. And now what this gives us is the old list, except the current list, is the ones that are just leaving.
So now there is an empty because nobody's leaving. But let's say, I don't know if we will see it for one frame. Let's remove it.
There was a blink.
And so let's add more clients. And we do it like this. And this is the string, this is the key, and we will remove this. So let's remove.
Now there are some left because this was not in place.
Let's restart it. add clients. Let's give it several different colors. Like this. Now remove client, remove a client.
Yeah.
So this is
It's a bit of a special trick how to detect that connections are going away.
even if we have just a spread of a connection, and we can detect who's gone.
Yeah. Okay. I think we covered everything that we wanted to cover. Questions? Any questions out there? If so, please put them in the comment. We have actually planned to do another episode with a WebSocket focused episode with a different twist to it. So that will be probably a moment to answer your questions as they arise. Operator?
But I guess
You first, sorry.
we didn't talk about. So now we just showed that we did everything locally. So the WebSocket server runs on this machine, and we started the HTML page from the same machine. But actually, in our multi-dome user installation, the user have their phones, and they start some website. So they give an address, and so website is hosted somewhere.
So earlier when I said I pull out my phone, that wouldn't have worked because as you showed here, we are always just opening
Some local
a local file.
HTML file.
Right. So that was a bit of a fake there. If you want someone outside of this one machine to access the website and then be able to access the WebSocket, there is some more to it, which we will not mention in this episode.
In this episode, but it's
Not-
a good topic for how to host the website
Yeah.
in vvvv as well.
And then it's even another step if you want this accessible over the internet and not only in a contained installation with a contained website. So there are some layers to this, but I think we demonstrated that the bare essentials you need to understand for making multiplayer installations with web interaction.
And fancy UIs.
And fancy UIs. Operator, what time do we have? 30 minutes, I guess 30 minutes.
28.
You're getting better, Jörg.
Questions? Silence, as usual.
They're for sure amazed. I was amazed.
Fair enough. You know where to reach us if you have questions. Thanks for watching.
Welcome.
Tune in next time when your YouTube alarms you about a new episode.
That's it.
That's it.
Thank you, Daniel.
Danke. Gute Nacht.